Hello, boys and girls. I'm going to do a little reminder for the week 2 math packet. I'm going to remind you about how to multiply decimals. That's the last 2 pages of your math packet for the week of March 23rd. So when we add decimals, we know that we have to line up the decimal point, right? And when we subtract decimals, we have to line up the decimal point. Sometimes we have to put a 0 in, so we might have to regroup, okay? But when we multiply decimals, we can just write the problem and just write it like that and ignore the decimal point for a while, okay? Then we multiply, okay? That's 12, 14, and we get our answer. And we look to see how many decimal places there are in the problem. In this case, there's only 1 digit beyond the decimal point. So on our answer, there's going to be 1 digit beyond the decimal point. Okay? You're going to see some problems that look like this. For some reason, this particular page doesn't put the 0 in front of the decimal point. You all know how I feel about that. We do not like to leave it naked, so feel free to put that 0 in there. But what you would do is stack it up. They don't have to be stacked up in any particular order. You would just stack them up like you would stack up any multiplication problem, ignoring the decimal point, okay? And then you would multiply 12, that's 16, 31. And then you count how many digits are beyond the decimal point. 1, 2, 3, 1, 2, 3, 1, 2, 3, and that's how many digits have to be beyond the decimal point in your answer. Okay, so no matter what the problem is, 21.3 times 0.6, right? That's 18, that's 7, that's 12. You just multiply it up, count how many digits are beyond the decimal point. That's how many is in your answer. You might end up with a problem that is has 2 digits down here. Okay, again, still you're just ignoring the decimal point. And then when we multiply with 2 digits down here as the second multiplication fact, we multiply 4 times 7. Okay, so that's 28. 24 plus 2 is 26. 8, 9, 10. Okay, and then we add a 0. Okay, because this is 10 times more than the 4. So we add a 0 to take care of that. And then 2 times 7 is 14. 2 times 6 is 12 plus 1 is 13. 2 times 2 is 4 plus 1 is 5. We add those up. Regroup if we need to. Okay, so now that we have our answer, we go back and count how many digits are beyond the decimal point. There's 3 digits beyond the decimal point, so that's how many digits have to be beyond the decimal point in our answer. Okay, now we know Eureka math has lots of different ways of looking at that. This is the standard algorithm. And so I would suggest that you just use the standard algorithm to solve this. If you have a different method that works better for you, that's okay too. But that's the way they get, after we've done it the Eureka Math way, in the end, this is what they end up showing us. So I just wanted to remind you how to do that. The last 2 problems on the page that says 31 look gigantic, but you're only multiplying by 1 digit. Here, and then on this one you are multiplying by 2 digits, so there's a lot of places you can make mistakes. So think of that as a challenge. I want to see how many of you can write that problem out correctly, right? 0.5679 times 2.7, and then do all the correct multiplying, okay, and then put the 0 for the next number that you multiply, and then add it all up correctly. We'll see how many of you can do that carefully enough to get the right answer. Okay, that's it for now. See you later.